Hey everyone, welcome back. In this video, we are going to build our own mini streaming system in the Node.js, but without using the built-in stream module which is available in the Node.js. But we will manually read a file chunk by chunk, write it to another file, optimize the memory, and even handle the gigabytes of data like a pro. Let's jump right in. So normally when you read a file using fs.read file, okay, so here what you're trying to do, you are loading the entire file into memory. That's fine for small files, but something like 10 GB file means it's a disaster. You could crash your app with memory overflow. So what is the solution for this one? The solution is nothing but streams. But what if we want to build our own version of stream like behavior? So how we can do this one? So let's try to do it. Let's start coding our own stream like solution using just the file system module. First we will open a source file for reading and destination file for writing. So for this one, what I will try to do is I will comment out this code. So here in this one I will create new one, that is nothing but async, and here this is our self calling file. Okay, done. And now in this one, first of all, what I will try to do, I will create I will open a source file for reading and also a destination file for the writing. So let's try to open the source file is equal to await fs.open, that is nothing but let's say that the source file, right? We are having a test.txt which is a small file, and this will be open for reading, and the destination file which I will try to open fs.open. Here I can do test -copy in the write mode. That's it. So now we are using the fs promises version to keep the things async await friendly. Now let's read a chunk from the source file using the read method. So here if you want to read it means, so here constant read result is equal to await. So here we need to do the source file dot read. So this is the method, and let's try to console.log of read result. Let's try to see the read result for this one. So here I will close it and I will run node copy, and here this gives us a buffer typically around 16 KB. It's not the whole file, just a small chunk. This is how we reduce the memory usage. So now the read method is returning you a buffer which is about 16,384, that is nothing but 16 KB. Now we need to loop over this process, read a chunk, write it to the destination, repeat until there is nothing left to read. So for this one, what we can do it, so here let's go into our code. So try to remove this one. Okay, and what I will try to do, so here we got the read result. So totally we got how much? 16,384. So if you want to get the bytes read means, so here you can use something like read result dot bytes read. So if you try to see it here, that is nothing but bytes read and buffer. This is an object. Now if you try to see, the total number of bytes it has been read is the 16,384. Okay, fine. Let's go here, and what I will be trying to do it is, so I will what I would be trying to do it is so now here what I would be trying to do it is, so let's try to do something like I will take the let bytes read is equal to -1. Okay, while bytes read is not equal to 0. Okay, not equal to 0. Then what I would be trying to do, so here I would be trying to take the constant read result read, and I would be getting the bytes read. So here I can do bytes read is equal to read result dot bytes read. So I will copy again, and here I would be trying to do that await bytes read dot write, not byte read, destination file. So I need to write in destination file dot read result dot not to string dot buffer. So the entire buffer I would be trying to write it. That's it. So now here we have written the code. So now let's go into our code, and here let's try to copy it. So it has been successfully copied. If you try to see the code here, this is the test.txt which is 3798. but when you try to see the test-copy, it is about 3824. So the file sizes are not matching. So now, we have written simple and efficient. We keep going, we hitting whenever the bytes read is equal to 0, which means that we have reached the end of the file. So fine. Now if I try to open this one, what is the file size difference and all those things? So let's try to open with Notepad, let's say Notepad or anything. So I will try to open this one, and here I will be trying to see at the bottom of the file. Okay, I will be trying to see at the bottom of the file. So here it is working fine. Let's try to open this one in our editor. Let's try to see what could be the issue in this one. So here this is the file which I would be trying to open, and here if I go to the bottom of this one, so here you'll be able to see a extra data, something like null is appearing here. So why it is happening here for this one? So you might be noticing weird null characters at the end of the file copy. That is because when we do the last read, the buffer might not be completely filled, meaning some of the bytes are just zeros. So for that reason, what we need to do, so let's try to console the bytes. Okay, sorry, let us console the buffer. So console.log read result dot, okay, let's try to read result it. That's it. So now if I try to copy it here, so here at the last you will be able to see all the bytes we are getting it as 0, and here also so totally we are getting 16,384 bytes, but here the buffer field is only 5,000. So that means remaining data everything is 0, and here also it is 0. So that means if the buffer is having some empty data, means it is filling with a 0. So what we need to do here, so we can get the read result dot buffer.length. So if you try to check the buffer.length, so here let's try to do the console.log read result dot buffer dot length. Okay, so now here read result dot buffer dot length, if you try to check it here, let's try to copy it. So here all the time you will be able to see here the 16,384, the buffer length is always 16,384. So now here let's try to write it here. So what can I do for this one in order to clear off this one? So here, so this is the entire code. Okay, fine. Now what I would be writing to do it is, so bytes read we got it. Now here let's say that here this is the thing. Okay, if bytes read is not equal to read result dot buffer length. Okay, read result dot buffer dot length, always it will be 16,384 only. So if it is not equal to this one, means so we need to get the index not filled. So index not filled is equal to index not filled. Okay, sorry, index not filled is equal to read result dot buffer not slice. We need to find the index of 0. So we need to find the 0 where it is there. So now we will try to create a new buffer. New buffer is equal to buffer dot allog of the new, with the new memory I will be trying to create index not filled. So now here you will be having 5,882, you will get the index. I am creating a new buffer with that memory size. So now what I will be trying to do, so here I will try to copy the entire thing, read result dot buffer not equal to, so here I need to copy only part of the buffer. So dot copy of, so I try to give the new buffer, and up to from where to where it will fill 0 source index and 0, and the total number what you need to fill is the index not filled. That's it. So it has been copied, and here I can do something like, I will copy this entire thing and I will copy the new buffer into this one, or else part it will be something like this. That's it. So now here what we have, we only write the meaningful part of the buffer, no trailing nulls. So let's try to test it. Let's test it out. So now here I will try to run this one. So entire thing has been copied, and if you try to see the file size for this one, so here if I go here and show more options and refresh this page, so we are having test and also the test hyphen copy. So why it is not getting copied again? bytes read is equal to this one, when bytes read is not equal to here, and read result dot buffer dot index of 0. Okay, destination file. Let's try to open this test-copy, and let's try to see the trailing slashes is there or not. If I try to open and if I go down to this one, okay, still trailing slashes are there. So what could be the reason for this one? If bytes is not equal to, if bytes read, so this is the only thing, right? If byte reads is not equal to read result dot buffer dot length, okay, then constant index not filled buffer dot index of 0. So here I am filling it, and read result dot buffer dot copy, and here, oh sorry, here I need to use the new buffer. So here you should store it in the new buffer. So this new buffer I need to use it. So this is the mistake, my mistake only. Let's try to see it here. Yeah, if I try to copy and if I see the here, so it is exactly the same. The file size now it has become exactly the same. So what will happen here, the thing is, so if you try to take it anything, so something like you are having this one, right, file hyphen huge, if you try to take that one also without any problem, the file will work. So here if I try to take it as source file hyphen huge, so not a problem, not at all, it will be a problem, it will not throw any error. So it will try to read it, and if you see the activity monitor also, so it is taking around, memory is around 12, 11, 12 something like that. So the memory is also efficient. So now here when we run the script, the copy is successful and clean, no weird characters, nothing we are having. When we copy text is about something like it will take around 30 MB of memory, maximum 20 MB it is taking in our thing. So there's a huge win compared to the loading. So the traditional fs.read file method is faster but uses too much gigabytes of RAM, not scalable. Now let's we have tested with our file huge thing, which is about 5 GB. This might take us few seconds, but again memory stays at around less only, so 17, 20, maximum 20 KB it is taking. So that's a huge accomplishment. So that's it guys about this one. So it will take some time depending on the system. So my system is slow, so that's why it will take so much of time. So we have just created a custom stream like system. We don't push data into memory and then pull it out like node streams, but the concept is same. And then, so like node streams, but concept is same. So we read a small chunk, we write it, and we repeat until it's done, all without blowing up our RAM. Of course, this is a simplified version. In production, you should wrap everything in a try-catch blocks and handle errors properly. But the takeaway here is, you don't need node streams to build something powerful. Sometimes a bit manual control goes a long way. That's it guys about this one. In the next video, we will do the same thing using the Node.js streams and see how piping can make this even easier. So make sure to subscribe and hit the bell icon. Thanks for watching. Drop a comment if you want the full code or have any questions or something like that. Don't forget to like, share, and I will see you in the next one. Happy coding.